Welcome students. We are given this question 3 raised to the power of x negative 3 raised to the power of y is equal to 234. We are expected to find the value of x and y given that x and y are element of positive integers. I'm sure most of you would know how to do this question, but I would like to show you 3 different ways to solve this question. Now point number 1, observation. Now watch here, x and y are given to be as element of positive integers. So if they would not have given this, then the solution for this question would be innumerable. So what they have done is they have made this question very simple by giving us the values, in other words by giving us the domain of x and y, that they belong to positive integers. So since they have given this question is solvable in maybe within 20 seconds. So what I wish to do is I would like to watch the left hand side. It's 3 raised to the power of x negative 3 raised to the power of y. So my observation leads me to believe that the right hand side can be converted to represent the left hand side. So I would like to rewrite 234 as 243 negative 9. Fair enough, right? If you were to subtract, so let me show you the subtraction. 243. From 243 you subtract 9, you carry 1. What do you get? You get a 13. From 13 you take away 9, you get 4. You have a remainder 3 and then you get 2. So 234. So this is a valid choice. Now what exactly is 243? Now if you were to observe this number, this is 2, positive 4, positive 3. 2 positive 4 is 6. 6 positive 3 is what? 9. Now 9 is divisible by 3. So that would mean I can easily divide 243 by 3. So 3, 8 3s are 24 and you bring 3 down. 3 divides 3, 1. So 3 times 3 is 1, and so clearly 243, a product of 3 times 81. Now what is 81 actually? Now I'm just showing you divisibility test for 3. If you are given a number, any number for that matter, in this case we got 81. If you want to know whether the number is divisible by 3 or not, just take the digits, add them and check if this digit is divisible by 3 or not. In this case it is divisible. So clearly 9 can be divided by 3. So 81, I know you all know 81 is divisible by 3, but just to make sure the algorithm is perfect and consistent, that's the reason I'm showing you all this. So 3 times 2 is 6, so remainder is 2, and then you have 7. 7 times 3 is 21. So 81 can be written as 3 times 27. Now what is this 27? 9 times 3 is 27. So I'm going to write it like this. 3 times 9, I already have a 3, I already have a 3 here. Now what can I do with this 9? I can rewrite 9 as 3 times 3. So I have a 3 here, and then I got a 3 here, then I have a 3 here. So what is this? 1, 2, 3, 4, 5. So this is nothing but 3 power 5. Now why did I do all these things? Just to be in a position to write 243 as 3 raised to the power of 5. And 9 is actually what? 3 squared. So let's go to the left side. What is on the left side? 3 raised to the power of x negative 3 raised to the power of y. Now you see the base, see the base, see the base, see the base. So the left hand side base is equal to, or I should say same as to the right hand side base. So equating, clearly you can see that x is equal to 5 and y is equal to 2. So this is the solution. X is equal to 5 and y is equal to 2 is the solution for this particular question. Now having got the solution, our problem is finished, our problem is done. So this is what we have got and this will be the solution. That's it. We don't have to go or look any further. Let me just give you one more method. In fact, I would like to give 2 other methods. Now let me write 3 raised to the power of x negative 3 raised to the power of y, and I get 2, 3, 4. Now what I wish to do is I would like to find out if 2 added with 3 added with 4, is it divisible? If is 2, 3, 4 divisible by 3? Now 2 added with 3 gives me 5. 5 added with 4 gives me 9. Clearly 9 is divisible by 3. So that would mean 2, 3, 4 I can divide 234 by 3. So let me see how many times. 7 3s are 21. I get a 2 and a 4. So 8 3s are 24. So I need a rough column. So 234 can be written as 3 times 78. So that is quite a revealing. So let me now go further and find out if 78 is divisible by 3 or not. So 7 positive 8 gives me 15. Clearly I can divide 15 by 3. So that is now 78. Let me check it out. How many times 3 can divide 78? So 3 times 2 is 6. I have a 1. And then 18. 6 3s are 18. 26 times. So I have a 3 times 3 times 26. So can I divide 26 by 3? 2 positive 6. 2 positive 6 is 8. Now clearly I know that 3 cannot divide 8. So that would mean I have a 3 times 3 times 26. So let me write this in this fashion. 3 raised to the power of 2 multiplied with 26. Okay, so now I got 3 raised to the power of x followed by 3 raised to the power of y. Now what I would like to do is I would like to divide both sides by 3 squared. So if I were to divide both sides by 3 squared, this is going to be 3 raised to the power of x divided by 3 squared negative 3 raised to the power of y divided by 3 squared is equal to 26. Now by the law of indices, what I can do is I think I would like to have one more. I will have to move on to the new page. So let me move on to the new page. So I've got 3 raised to the power of x divided by 3 squared negative 3 raised to the power of y divided by 3 squared is equal to 26. This is what I've got. Right now, a raised to the power of m divided by a raised to the power of n can be written as a raised to the power of m negative n. I can very well do this. So this is going to be rewritten as 3 raised to the power of x negative 2 negative 3 raised to the power of y negative 2 is equal to 26. Now how can I write 26? I can write 26 as 27 negative 1. Fair enough, right? So let me substitute the left hand side. In fact, let me write the left hand side. 3 raised to the power of x negative 2 followed by 3 raised to the power of y negative 2. Now what is 27? 27 is 3. Let me show you that. 3 times 3 times 3. So what is this? This is nothing but 3 raised to the power of 3. 3 3s are 9. 9 times 3 is 27, which can be rewritten as 3 raised to the power of 3. So let me place the 3 raised to the power of 3. Now what is 1? 1 is nothing but 3 raised to the power of 0. So that's what I'm going to write it there. Now what's on the left hand side? I get 3 raised to the power of x negative 2 followed by 3 raised to the power of y negative 2. Now just compare the left hand side versus the right hand side. Now the bases are same, and you see if the bases are same, you can equate the left component, the left hand side versus the right hand side. So this would mean I can clearly state that x negative 2 is equal to 3. Moving the 2 to the other side, I get x is equal to 3 positive 2, which means x is equal to 5 for one side. And similarly, comparing y negative 2, in fact comparing 3 raised to the power of y negative 2 with 3 raised to the power of 0, I would get y negative 2 is equal to 0. Moving the negative 2 to the other side, I get 0 positive 2, which is y is equal to 2. So y is equal to 2 is one solution, followed by x is equal to 5. In fact, this would be the solution. X is equal to 5 and y is equal to 2. This would be the solution. If you are writing it, you can write it as 5 comma 2. Now this is method number 2. I want to show you method number 3 also. Now clearly you can see the same solution was obtained in the previous method also. Now let me show you the third method. Now you got this 3 raised to the power of x negative 3 raised to the power of y is equal to 234. Now imagine you have failed to observe that 234 can be expressed as an exponent value of 3, or you are not in a position to decompose the right hand side, so you have missed that first check. Let us just imagine, okay, let us just imagine that you have missed that first check of observation to fragment the right hand side 234 as some exponent power of the base. So that is skipped, or that is slipped by you, or you have not observed that. So that skip has already taken place. So in that case, this method will come in handy. So what is this method? What I would do is I would just take 3 raised to the power of x and I would rewrite this as some power of y. How do I do that? Simple. You add and you subtract y. So in this case I will start with subtracting y and then I would add y. Now this can be rewritten by using the law of indices. A raised to the power of m positive n can be rewritten as a raised to the power of m times a raised to the power of n. This is always possible from the laws of exponents. So I'm going to club these two together and rewrite this as 3 raised to the power of x negative y times 3 raised to the power of y, and then I'm going to replace in place of 3 raised to the power of x this component. So let's do that. So this is going to be 3 raised to the power of x negative y times 3 raised to the power of y. Negative 3 raised to the power of y is equal to 2, 3, 4. Now I'm doing all these things because of the fact that x and y have element of z positive integers. So that is very much important, right? Because 3 raised to the power of x negative 3 raised to the power of y is going to give me a positive quantity. So now what I wish to do is, if I were to take 3 raised to the power of y out, then I would be left with 3 raised to the power of x negative y, negative 1 is equal to 2, 3, 4. This is what I've got. Now imagine that you want to reduce 2, 3, 4. That you are not sure of the divisibility, you are not sure of any other things, but all that you want is you want to reduce this. So the first and foremost thing that you would do is you will find out the factors of 2, 3, 4. Right? Say you start with 2. You say 2 times 2 divides this 1 time, so it's going to be 2. You bring the 3 down and 2 divides 3 one more time, and 2, 1, 4, 7. So you get 1, 1, 7. Right? So 2 is a factor, so you place that. But this multiplied with 1, 1, 7. Now this is the odd number. 2 cannot be used. So eventually or inevitably you have only number 3. And of course, if you know the divisibility check for 3, you would apply it. But as I mentioned to you, you are not aware of it. So the only case that is left here is to try out by trial and error. So 3 divides 11, 3 times 3, 3s are 9. So 9, 10, 11, you bring 2 down, you bring the 7 down. So 3 times 9 is 27. So you have a 39. So you are going to be writing this as 2 times 3 times 39. Now with some observation, you know that 39 is divisible by 3. So it's 1 time here, and then you have a 3 here, and you bring the 9 down here. So you're going to be writing this as 3 times 13. So this is what you got. So now all of these things are the factors. Now you can clearly see they're all prime numbers. So you have to be a little bit careful. But the only thing you have on your side is you have 2 3s are there. So that should give you some comfort. So this is going to be written as 3 squared. And 2 times 13 will give you 26. So you write that down, and on the left hand side you have 3 raised to the power of y times 3 raised to the power of x negative y negative 1. So this is what you've got. Now clearly you can see that the bases are same, so you can connect these two together. So that would mean you get 3 raised to the power of y is equal to 3 squared. So from here you know y is equal to 2. That's fine. Now having obtained this, y is equal to 2, you can now connect. Now you can compare 3 raised to the power of x negative y followed by negative 1 to 26. Right? So this can be rewritten as 3 raised to the power of x times 3 raised to the power of negative y. So this, because of the fact that a raised to the power of m negative n can be written as a raised to the power of m times a raised to the power of negative n from the law of indices. So that's exactly what I'm doing. Now this negative 1, I can push it out to the right side. That will become a positive 1. So that's going to be 26 positive 1, which is 27. And here you get 3 raised to the power of x times 3 raised to the power of, now y value is positive 2, but you got a negative sign, so you place the value there in this fashion. Now you can bring it down. So 3 raised to the power of x divided by 3 squared, that's going to be positive there, and 27. So let me use this part of the page. So 3 raised to the power of x is equal to, I cross multiply, I get 27 times 3 raised to the power of 2. Now I can write 27 as 3 raised to the power of 3 times 3 raised to the power of 2 there. I can add these two things by the law of indices. So that's going to be 3 raised to the power of 3 positive 2. On the left hand side I got 3 raised to the power of x. So this would mean x is equal to 5. So I get a value x is equal to 5 and y is equal to 2. So this is a solution and this is a solution. So eventually we are getting the same value as we have obtained. Now the question is, if you are not taking, say for example, you are just holding on to 3 here and you are multiplying 2 with 39. So that is going to be 78 times 3. Okay, 78 times, let me show that. I hope you are able to see it. Now if you are not reducing this 39 as 3 and 13, but you are just stopping over here, that means you are having a 3 here and then you are multiplying 2 with 39 and then writing it as 78, and then on the left hand side you got 3 raised to the power of y, and then you have 3 raised to the power of x negative y negative 1, and then what are you doing here is you see that, oh, I have an exponent 1 here and I got a y here and the bases are same here, so y is equal to 1 is a solution. You might conclude like that, right? And then you can proceed on taking the value of y is equal to 1 into this. That will not work for the simple reason is you have not completely reduced the quantities that you see here. Now if you can see here, all these things are prime factors. That means the GCD is 1. So what it means this is the maximum reduction that is achievable for this quantity 2, 3, 4, and that is critical. If you don't do that, if you simply start off with this particular quantity, say 3 raised to the power of 1, and then come to a solution that y is equal to 1, you will not be able to solve this question. Even if you are able to claim that you have solved it, it is incorrect. So that is a very vital point of observation that you will have to know here. The reason being, methods like this are, number one, they are tedious. Number two, you have to be very watchful because you are bound to make mistakes whenever reductions is involved, because most of the times we may not know how far a number can go, because divisibility is a complex topic as it is. So having mentioned that, let me move on. Let me move on to give you a bonus method, a fourth method. What is the fourth method? The fourth method, some of y'all will have a claim. Why is it x is equal to 5 and y is equal to 2 are the only solutions? Why? What if they are other solutions? This is perfectly not possible. I'll just tell you why. Now I got 3 raised to the power. This is method, okay, this is method number 4. The method number 4 is to ascertain why x is equal to 5 and y is equal to 2 is the only solution possible for this question. 3 raised to the power of x negative 3 raised to the power of y is equal to 2, 3, 4. Okay. Now what I'm going to do, I'm going to rewrite this as 3 raised to the power of x is equal to 3 raised to the power of y followed by 2, 3, 4. Now what I want to do is, probably I will just move this to this left side. So this is going to be 3 raised to the power of x negative 2, 3, 4 is equal to 3 raised to the power of y. Now you can either start to connect or observe these two together or these two together. It doesn't matter. Now just check on the left hand side what happens. Now if I were to take, now x and y are given to be element of positive integers, so that means integers, okay, so leave the 0 out, so positive integers. So I start with 1, I start with 2, I start with 3, I start with 4, I start with 5, I mean it goes 5, 6, 7, so on and so forth it goes. Now at the value when x is equal to, what should I say, when x is equal to 5, 3 raised to the power of 5 gives us a value of 243. Okay, when x is equal to 5 over here, 243. So 243 minus 234. So what is that? Let's just check that out. Let me use this space. 243 minus 234. So this is going to give me 9. Okay, 9. That's the first value, 9. Now start increasing to the next value 6. Okay, so what happens? I need to show you. A 3 raised to the power of 6 is nothing but 243 times 3. This is equal to 3 3s are 9, 3 4s are 12, 1 3 2s are 6, 729. Now 729 minus 234. What is that? Let me just show that to you. 495. Are you following me? See the value, see the jump. See the jump I'm getting here. So this, for values of x contained in z plus, this is going to be an increasing function. On the right hand side, this is also an increasing function. So two increasing function, if they are going to be meeting, they will just meet at one point. One point, one coordinate, and that one coordinate will correspond to x is equal to 5 and y is equal to 2. This is the only point where the function will meet. So that would mean we only have one solution for this particular question. Thank you, students.